How's it going, everyone? Hey, William Gonzalez again. We are going to look now at quick recap of this application state and network connectivity as a way to understand when we need to design these front-end systems, what are the fundamentals that we need to know, as well as the area of responsibility that we take care of us. Briefly describe is that now this network connectivity actually happens, and then look at the technique used as a way to make that happen, to now communicate with APIs to servers, and what is the trade-off of using that. So this is a course taught by Yvonne Ray, software engineer that has previously worked with JetBrains over 3 years, and now he's currently at Meta, where here it's a, hey, this is now the fundamentals that you need to know, especially if you are going to dedicate as a UI specialist, you're going to be a UI engineering, when it comes to build all of these web complex applications at scale. So this is now the structure of this course. So we went through actually describe what is an application made of, front-end, API, and back-end. And then now in the case of the front-end, which is what we care about, what are the areas of responsibility that we need to handle that? So we need to know how we're going to communicate to the server, so API communications, as well as the way of how we're going to manage and store our data, which is data management. How we're going to handle is now this specific or complex user interactions, and what are the solutions right now that the browsers provide as a way to see how that works, and what are the trade-offs as well. What is the most common use case for those particularly patterns, whether it's for intersection observer, where this is now this tool that the browser provide for us as a way to solve this common use case. Marketing, right, for analytics, as a way to check if this application, how long a user is now to, how long a user took to see this content, or you want to know is you want to show is some content as the user scrolling, like virtualization techniques, as well as dynamic loading or lazy loading components. You want to load now CSS files or JavaScript as it is, as at runtime. And also you want is to for example is when you're writing these text editors applications, for example like Notions, or drawing tools, you might want to use is the mutation observer as a way to handle is when the attributes of that HTML change, or the content, or any of its child elements. And the resize is, for example, well, if you want to actually is when you need to design is when you need to create responsive design, or for graphic tools or charting tools, right? This is widely used, especially on the trading, when you want to show is now this particular graph and show that properly. But in any case, this is just to cover and to explain what are the most common complex patterns that we as a UI developers needs to deal with, and based on the business needs, how can we use some of the inner mechanism for that, and then take a look at the application state, which is now another another responsibility that we need to deal with, similar to the asset management. So something that we're going to talk about in the next video. But in today's video, we're going to now make a quick recap of this app state management as well as the network connectivity. So anytime you want to now store and manage data, depend of the type of application you want to build, it is important to understand what is the type of data that we most of the time we store in our front end, which is the configurations, so user themes, fonts, accessibility, and that kind of thing, and also when it comes to the that's quite interesting. Anyway, and also when it comes to so the other type of data that that we source are, well, local states, UI local state, as well as data from the business, from the server, right? And each one of those data has its own properties. So, for example, how you're going to access, who can access to this, how often we're going to read and write this data, and how what is the size of this. So on each one of these property, that's when we say on the app state management, we want to now focus our attention, or the goal of this will be is to minimize the access costs. If you implement some search in operation, we want to minimize those searching operation, as well as the size of the application, right? So minimize the memory use as well. So we also will look at how can we do that, some of the techniques that is doing. For example, Redux is one of them, or even if you implement your own applications, this is something that you might like to implement that. Okay, so that is, if you want to now improve the access or minimize the access cost, normalize your data. This is a concept that comes from the database engineering, where the idea is to minimize the idea is to avoid redundancy and inconsistency. Redundancy and inconsistency while improving the access of this data. So they are creating now some sort of index to do that. So in the case of normalization, you say, hey, if you have this particular data objects, you have now several normalization steps. Okay, and there are seven. Right now there are 7 of them. When you are developing, if you're a front-end application, you usually is 1, 2, or 3. Most of the time to the second normal form. So the first normal form say, hey, let's go now and let me show this. Okay, let's go now is to minimize. Let's go now to make all of this atomic. Let's now go to make all of this. Let's now make these objects and all of it is property atomics. All right, and they're going to depend on the primary key. Right, so the whole point of using this normalization is, as I mentioned before, is for performance, is to know how you structured your data, and it is easy for other developers to read that as you follow this particular discipline, this normalization steps, and make it easy to maintain. So this is the first normalization, right? Something that we did here. All right. This is the example here. So we extract that data into a particular entity, where we're going to put now the primary key and as the key, and all of the data that we want to, and all of this atomic data here. So the second form, it say, hey, non-primary key must. So non-primary key must be non-primary key that should depend on one yeah, should depend on one or the entity primary key. This is just a fancy say to say, hey, let's go to create a new table where the primary key, this identifier, will have all of this property for this new table, for this new representation. So that's why you create now a new object that follow is that particular thing, right? So you take a look at this. Why not? All right. So if you take a look now at this particular image, is pretty much what it's doing here. You know, it's taking now from the previous slides here, from this is the first normalization. Hey, make all of this property atomic and depending of the entity primary key. So those non-primary key should depend on a entity primary key. So it means that this particular entity, this particular table must have a unique ID followed by the properties. But the third form normalization form say, hey, no. All of this non-primary key must contain or must depend on the ID. All of this come from the concept of a relational database. Relational database, or this algebra relation, is this generalization of relationship. But again, the idea here is that if you're going to now improve or to minimize the access cost, use this normalization. So for example, Redux actually is using that behind the scenes. And if you need to implement some search in features, then you should rely on index. There's also things called like inverted index or inverted index table, right? Where the whole point of this is that your key will be now matched is the content or the composite keys, which is if you want to now improve, for example, if you're building a chat application or an e-commerce and you want to search now is for your users in your user list, your contact list, well, one way to improve that is using this inverted is by using this inverted index table, right? Where now each one of those primary key identifier will now will be is a collections of prefixes, right? It's a way to improve that. Again, this is only if you really need to do that, and if you need to show some of these users that are relevant for that, to show relevant data, then is when you started to offload in the data to some kind of a storage. This is as a way to minimize is the size of the memory that it needs to be handled by your applications. So you offloading that to other devices rather than your main memory. So this is now the TLDR of this, right? But the thing here is that anytime you want is to actually implement an state, or in this case, you need to handle data here, so data management. You need to store and access data. This is some of the recommendations that you can do, right? So first thing first, know the scale of your data. How many data that we're going to store here, and then what will be the structure of this data. Start from there. So if you need to minimize access time, well, normalize your data. If for some reason you need to implement some sort of search functionality in your application, which most of the time we need to, depends on the kind of applications, then use index, right? It can be inverted index table or index table, but use index. And as the application grows and more memory is being used as a way to show more relevant data to the user, okay? This is when you need to consider when you're gonna offload this data. whether it's by using its local storage or season or IndexedDB, right? The subtle difference between each one of them is season storage is only per tab, so once you close a tab, it's gone. The local storage is persist even when you close the browser, and the IndexedDB persists even when you turn off your browser. That's a way to make sense that we didn't lose our mind. Okay. Okay. The browser, season, local storage, and it is safe to say season, local storage, and the stay season, local storage, and the through computers shutdowns. Okay. Exactly. So, there you got it. So, in this case, minimize size management here, which is this one. So, season storage persists per tab, local storage persists even after you close the browser, and IndexedDB persists through computers shutdown. Right? Good, good. And now we are talking about is the network connectivity, right? Network connectivity. So this is just when it comes to actually talk or this API communication, when you need to talk to your API, to a server, okay? And let's say you want to now hit an endpoint or to talk to you have now an application that you need to actually talk to an online orders or to a chat with employee, right? So here we're gonna see how we can communicate with our servers. First things first is to describe the process of what happens here. That's going to describe the process. So, okay. So let's go to describe the process. Okay, so describing navigation, right? You can say is this. So describing navigation, right? So describing navigation. Exactly. This is what we need to first understand. What is the OC model, right? This is an open system interconnections that was developed back in the 70s because there were now a protocol war between the proprietary and the public. So X25 is now something that was used on public networks, and then you have now proprietary protocols or proprietary or switch package protocols, right? That all of them were competing in the market. So luckily for us, now we got the OC models, and that also is the successor of the X25 protocol. All right, but this is now provide a more complete overview of how now data must be processed and what are the information that we need to add to this data as a way to now let this computer send that data in this package that contains all of the information needed to reach to the destination. So that's why we have now is the several layers here, where the applications is the top of that. This is now when the user interactions happen. So this is when applications now access to the network service. Then you have now season or the presentation. This is when ensure that the data is in usable format. This is when ensure that data is in usable format, and when the data is encrypted. Okay. Then you have now the season, which is now maintains connections, and it is responsible for controlling port and seasons, right? Absolutely. This season is something interesting because it's managing its port, it's managing connection, it is responsible for controlling port and seasons. Important to understand this part, the season with double S. Season with double S. All right. So we got the application, and we have the presentation that ensures that the data is in the proper format, and this is when encryption happens. And then it's going to add a little bit more of information to say what is or manage is the is to manage or is to maintain connections and control ports and seasons. All right, this port, this maintain connections, and this port is where now the data is the door where the data is going to pass through. All right, so maintains maintain is the coordinate, maintains the coordinate, okay. So season is controlling is season, okay, and managing connections. Okay, so controlling is ports and season and managing connection. This is season. And then you have now the transport layer, which is say, hey, what is the protocol that we're gonna use to transmit this data, which is TCP or UDP. So TCP is now connection based, which require you to do a handshake as a way to all of these two nodes actually know that the data is, as a way to make an agreement that from that moment on they're going to receive this data, and the UDP doesn't care about it. It's connectionless. It's like, I'm going to send this data. The main use case for this is for voice over IP or streaming data. Then you have now the network will say, hey, this information that I'm going to add to the data is to know what is the physical path that it needs to, that the data will take, right? The network. The data link say, hey, that's going to define is the format of the data of that network. Interesting. Is that because now the network say what'll be the, okay, because the network or the IP say what'll be the physical path that this package needs to go, or the data will take. All right, now we need to create a format for the network. Interesting. Okay, now we need to create a format for the network, because if we send message, so if we know what is the physical path that you need to take, all right? But if we send things with different formats, okay, those who are responsible to carry out and pass that data, they wouldn't know what is this, okay, because there is no consensus in there. That's when we had the data layer. It's as a way to say, hey, let's gonna add this format on the network, right? Let's go to define the format on the network. Let me actually, as a way to clarify that, integration, compression, and translation, decision layer, the transport layer, the network layer, package creation, transport, and package assembly, the data link, okay, frame creation and transport, transfer between net, exactly. Hey, this is now the format, okay. This is now the format, okay. So hey, this is now the format. This is now the format that this data from the network is gonna travel, okay. Transfer frames between net, and then you get now the physical layer. It's a very similar to the network layer, except the data link layer facilitates data transfer between two devices on the same network. It facilitates, okay, it facilitates because what? Because they have now a format. The data link layer takes package from the network layer and breaks them into smaller pieces called frames. Like the network layer, the data link layer is also responsible for fault control and error control in intra-network communication. So because it split this into small frames, okay, into sequence of data that are easy to understand by two devices, because they follow is this format. And then the physical layer, which now it has all of the information that it needs, and then send these raw bits of data through that. Okay, and transmit raw bit of data through the physical medium. This way of describing this is something important as a way to now understand is how this navigation work on the browser, and then what are the techniques that we use it. So when we navigate, this is now the navigation, okay. So when the user navigate to a particular URL, the browser now fire this, pass through the OC models, and then it send that to the ISP, where this ISP, Internet Service Provider, contains all of this DNS server to actually get the URL and see which one of them match with the records to get now the IP, this internet, the address of the internet, or this physical address here of the internet. So this IP internet protocol, this IP address now is sending back to the browser. The browser, depending on the implementation, it can catch that as a way to prevent to actually call that as a way to skip is the DNS lookup, all right? And then is when it started to establish if you are using now a TCP connection, okay, which is usually if you use an HTTP. But what happened here in this phase, once he know what is the location of that computer, it say, okay, now let me establish now a handshake here. This TCP handshake, if you want to establish a connection base, this TCP handshake, which is made of this three-way handshake, which is the sync, send that a package is sent to from the client to the server, sync, the server say, oh, I get that, it send now this sync to the client, the client receives that, package, and then say, okay, now let's the acknowledge, and therefore the communication start. So it send out the acknowledge, and then is when the communication can happen, which is you can now send, for example, hypermedia content using HTTP, using the HTTP verbs, right? That's quite interesting. So this is something that, especially when you want to add a new layer of security, you add now is this TCP negotiation, or the TCP TLS negotiation, which is now a new handshake, or add a handshake to which cipher we're going to use. These ciphers can be asynchronous encryption, AAS, RAS, or Diffie-Hellman. Okay, synchronous encryption, which is, hey, we're going to now is encrypt the data, is AAS or Cha-Cha-Cha-20, okay, which is for fast encryptions, especially useful for mobile applications. And then you have the hashing. So this hashing can be whether it's in a SHA-256 or SHA-304, 3A4. But the point of this is that this is now an extra layer of security that you are adding to your communication, right? Because if you don't have that, everybody along the way can actually read this, okay? And this might this might be something quite weird, especially if you don't know that. But here we're gonna see is now what are this particular protocol after that. So after you send that, okay, so after you establish that TCP handshake with TLS negotiation as a way to secure the connection, then you're going to now perform the request, usually using an HTTP GET or any of this verb as a way to send data or to start the conversation with the server. So get for data or sending data. And this is when now we're starting to look at what are those protocols that allow us to send data. So we have now HTTP1, which is connection based, okay, similar to HTTP2 and WebSockets. Both of them are inspiration from this, is similar to the server event. So the subtle thing here, okay, and here we're looking is now communication techniques, right? Communication techniques. Communication technique, TCP base, okay, TCP base, TCP base, all right. TCP base, and then you have the UDP base. Interesting. And UDP base, which is now WebRTC. Okay. Then you have Quick, which is a proprietary protocol. Quick protocol. Exactly. okay. Mm-hmm. 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 Protocol ossification. Quick handshake. Initial hello. Init hello with certifications and fin. And then now pass that finalize, and then the data. Mm-hmm. Interesting. Very, very, very interesting. Very, 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 very interesting, bro. Very, very, very interesting. Quick Web RTC. But this is connection based. Quick Web RTC, and then HTTP 3. Okay. Yeah, this is a comparison of TCP comparison, which is TCP based connection versus quick. Okay, makes a lot of sense. Makes a lot of sense. Makes a lot of sense. So what we're gonna look at this is this particularly TCP-based connection techniques here. Exactly. We are going to focus our attention in TCP based connection. Okay, we're going to focus our attention in TCP based connection techniques. Okay. Yeah. So that's what we have now is this TCP based long polling. Interesting. Let's get into this.
One is to track new orders. The second one is to chat with employees. Fetch request and call the server every 20 seconds. So what are the issue of the long poll?
Okay.
For getting new orders. So the first one is the HTTP protocol. Since we need to establish the three-way handshake with the server, it's relatively slow. It will be pretty slow. And when we establish the HTTP connection, we open a new TCP socket, and TCP socket apparently takes CPU, and it also drains energy as a result.
Yep,
and it also has the property of an efficient network usage, because when you establish the connection with the server, you send the metadata, which is the headers, with the request. And if you are on HTTP 1, then the header data is not compressed, and you may end up sending 50 kilobytes every request of just header data. And HTTP 2 improves the situation by compressing the headers, but we still have this three-way handshake that we need to establish. And there is one thing is that the long polling and short polling actually drains the battery of the mobile devices.
Establish the connection it costs a lot of CPU processing power, because anytime you need to open a connection, open a port,
it will be pretty slow. And when we establish the HTTP connection, we open a new TCP socket, and TCP socket apparently takes CPU, and it also drains energy as a result. And it also has the property of an.
So it costs a lot of CPU time, because one, it costs a lot of CPU time since it needs to open a. This is quite interesting. So it costs a lot of CPU time since it needs to open a. That's right. Since it needs to open a TCP port. Since it needs to open
efficient network usage, because TCP socket apparently takes CPU, and it also drains energy as a result.
Because it costs a lot of CPU time. It costs a lot of CPU time since it needs to open a TCP port. Therefore, consume more power.
And it also has the property of an efficient network usage, because when.
So as a result, it drains battery.
You establish the connection with the server, you send the metadata, which is the head.
As a result, it drains battery.
Headers with the.
But it drains energy battery. It drains energy.
Request. And if you are on HTTP 1, then the header data is not compressed, and you may end up sending 50 kilobytes.
It's an inefficient net usage, since you need to send the headers data in each request. Since you need to send the header. Okay, since you need to send the header data in each request. Since you need to send the header data in each request.
Bytes every request of just header data. And HTTP 2 improves the situation by compressing the headers, but we still have this three-way handshake that we.
So HTTP 2 improved this by compressing the headers. Interesting. By compressing the headers, but we still have the three-way. We still have the TCP 3 handshake, or three-step TCP three-way handshake. TCP three-way handshake.
Need to establish. And there is one thing is that the long polling and short polling actually drains the battery of the mobile devices, because you need to maintain your TCP socket open. And when your TCP socket is open, the key thing how the mobile module is structured. So in your phone, you have your mobile network module has two modes. One is mono. It's basically receive only. When this module in the receive only mode, so it's very energy efficient, but it can only receive the data. But there is also a duplex mode where you can send the data and receive the data, and it's not energy efficient as a result. So when we use the long polling, the mobile device utilizes a duplex antenna. So it receives the data and sends the data. And if we run the quick experiments, for instance, we have the 2000 battery, and we know the average time, the average energy drain. So it takes only almost 4 hours to drain the full battery by maintaining just one socket opened. And I attached a link to the research paper that you can use to, if you're interested in reading the whole paper.
This is in 2019. Inmaculada Ayala, a Mercedes Amor y Lidia Fuentes. Scientific Programming. Advertising. Wiley Online Library. Oh, okay. Okay. Oh my god. Okay. God damn it. Welcome, man. Welcome. Welcome. This is one of the problems of this long polling. You can start it by using this async operation using the web API from set timeout, right? And what happening is that behind the scenes, you said, hey, I want you to now triggering this long polling as a way to get updates from the server. So the long polling is something that it requires a lot of CPU, because anytime you actually is now doing this long polling is on the client side now creating this connection, Ajax connection, or this promise-based connections with HTTP or HTTPS, right? So now the CPU needs to actually open a TCP port, which it drains energy. And not only that, since the headers data is sent on each request, HTTP to improve this by compress that data. But even though you need to do this three-way handshake, right? So if you can imagine that in your mobile applications, if this is something that you're delivering into your mobile applications that you have in that smartphone, is the mobile network model. This is something interesting. How do you mobile architecture, bro? Diagrams. No, but this is not. No. Mobile. No. You don't get it. Mobile device architecture. No, but this is a protocol or a standard. Exactly. Design. Jesus. Get me a trustworthy resource about mobile device architecture diagram. Mobile phone architecture diagram. Guide to app architecture by Android developers. No, but this is how they can build. Okay. Okay, okay. No, it's okay. Well, any case. Yeah, but where all of this came from? Okay. ResearchGate, Eventa, and that kind of thing. Nexus 5 block diagram. Doctor of Engineering, Université. Cellular baseband, application processor, LCD screen, LCD card, power supply, which is an event bus that communicate with the Bluetooth, WLAN, and GPS. Cellular FS transceiver. So because of this architecture, right, as a way to understand now why this is important, especially for mobile, this is now mobile architecture, architecture, yeah, mobile architecture. mobile architecture. All right. Because you can have now one model that is say, hey, receive only, and the other is for data bidirectional. So one of the pros of long polling is that it's easy to implement. It is not required for, it's easy to implement. It doesn't require you any infrastructure, and 99.9% of the server will support that, right? So, however, there's some cons because it's gonna drain. It's gonna drain energy from the CPU anytime you need to actually make this long polling, and you may wonder is what long polling is about. Long polling. It's the simplest way of having persistent connection. So what is a problem that this is solving is persistent connection. It's persistent connection. So the goal of problems and the goal, which is persist connection, persist connection, the connection persistent, connection persistent, right? Connection persistent. So far so good. So we also look at what is the downside of this, because data is the network and data is inefficient, since on the HTTP you need to send the headers on every request, but HTTP 1.2 actually compress that, which makes things much more performant. And latency can degrade very quickly on mobile networks. And latency can degrade frequently because of mobile network. Because not only that, the other problem here is latency, especially on mobile devices. So problems. Energy consumption. So problems. Energy consumption. Exactly. Problem 1, energy consumption. And problem 2 is latency. So imagine that you are now driving. Imagine that you are now driving, and anytime you have to switch between antennas, you need to also establish that connection as well.
Or in a fast car. And also, the problem with the long polling is that you need to re-implement reconnection. Every request to the server, which is done through the REST API, is stateless. So you don't know exactly.
Exactly. You need to implement is now reconnection.
You will lose the state, and you will need to re-implement some infrastructure on the server side to do this. So it's in the long run, for the mobile applications, it's actually costs more to support the long polling, money-wise, of course. So what is the cost more?
Holy crap. Exactly, because after all this is a stateless, HTTP doesn't remember things. You need to actually implement your own reconnection solution. Exactly. Latency. You need to implement now you will need to implement a reconnection solution. Interesting.
To support the long
which is something that now WebSockets allow us to do this.
So the WebSockets is the fastest way how can we transfer the data between the server and the client. So the WebSockets is the first alternative that we could potentially use to long polling is the service and events. This is the server push technology.
Exactly.
So it's a slightly different. So it's based on HTTP2, and the way it works is when you establish the connection with the server, the duplex communication is used only when you do the initial connection, just the initial freeway handshake. But the rest of the connection is basically the server pushes the data to the client. So in case of the service and events, the duplex antenna is not used. We only use the receive-only mode, and we do not drain the energy. Although we still have an issue with the reconnection where we need to do the freeway handshake, but the huge difference with the service and events that the reconnection is implemented on protocol level, so you don't need to handle that on infrastructure-wise. So you can always resume from the place where you started. And the huge benefit business-wise for using service and events, it's very easy to scale. So for instance, if we have multiple instances of the server and one instance is died, we can just forward the request to a separate instance, and because we can always resume from the previous place using the service and events, so it doesn't matter for us which instance will respond. So since the service and events is HTTP2 based, it also utilizes the TCP socket differently. We're going to talk about HTTP2 protocol just in a few moments, but the huge benefit of HTTP2 is because it has the multiplexing feature. The multiplexing allows us to open 200 requests within one single TCP socket. So this means while multiplexing just in a few moments, but the huge benefit of HTTP2 is because it has the multiplexing feature. The multiplexing allows us to open 200 requests within one single TCP socket. So this means while HTTP1 to fetch 5 resources, we had to open 5 TCP connection, which is much less efficient. So the service and events is generally much faster than long polling because it also doesn't send any junk data. So we don't send any unnecessary headers, and we receive only the data that relates to the content. And the summary for that is there are definitely pros for service and events because the connection is handled automatically. It's very battery efficient from the mobile device perspective, and it doesn't send any the overhead data. And the horizontal scaling of your infrastructure is much easier when you use the service and events. The cons, though, you can't push the data to the server, and only the string data is supported by returning this. So you will need to parse the text payload that you send from the server. And when you need to use it, it's good for both desktop and mobile web applications. And it also provides a very good performance. So the performance comparable to the WebSockets that we're going to discuss on the next slide. And it's very good for streaming the large text data if you have this case. And the reason why you would avoid this is if you're building a very simple desktop app, so then you'll be fine with long polling. You don't need to really overcomplicate the architecture of your app. So the WebSockets is...
Okay. Server side, no, server event. Because this is now... La maldita madre, vale. ¿Dónde coño la madre siempre la agarra? Siempre lo está agarrando con razón. Agarrando siempre ahí. No sé, yo sí decía, pero este segmento se está... ¿Sabes? Server send event. This is a push technology, man. So you can now listen to this particular domain with credentials and then start listening to those events. So on message, you're gonna now create that. So when the server, so when the server is starting to use this, so when the server send a message, you're gonna get that. But this is to implement is push technologies. Interesting. But this is connections open on the server. A permanent dedicated connection. Okay, that's quite interesting. It's because okay. Every second send a ping event. It's a global object. Say time and the current date. And then you say counter minus. Return the counting of the output buffer. In this case, this. And the other is flush. Flush system output buffer. What does it mean, flush? Rains flush. Okay, flush system output buffer. In sleep 2 seconds. In sleep 2 seconds. In sleep 1 second. Closing event stream. Oh, okay.
Is the fastest way how can we transfer the data between the server and the client. So the WebSockets is the first alternative that we could potentially use to long polling is the service and events. This is the server push technology. So it's a slightly different. So it's based on HTTP2, and the way it works is. So the first.
¿Qué vaina es? Hijo. Ay, ¿qué te digo? Okay.
The first alternative that we could potentially use to long polling is the service and events. This is the server push technology. So it's a slightly different. So it's based on HTTP2, and the way it works is when you establish the connection with the server, the duplex communication is used only when you do the initial connection, just the initial three-way handshake. But the rest of the connection is basically the server pushes the data to the client. So
so right. So that'll be all for this video. Take care. Bye bye.